Today we are moving on to 7.8 graphing functions. This is going to be the last new lesson that you guys need to know for your quiz coming up on Monday. It's going to cover sections 7.5 through 7.8. Number 1 is asking us to graph the function. Always use -1, 0, and 1 as the domain. So in your homework tonight, it's just going to say graph the function. It's not going to give you a domain. So just know for your homework, you're always going to use a -1, 0, and 1. Okay? Let's talk about the domain. We talked about that yesterday. What is the domain? Your x or your y? Your x. Okay? So it just gave you what your x is going to be right there. Now, how many numbers are in my domain? 3 of them. So we are going to go ahead and rewrite our function 3 times. In order to graph a function, we're going to start off with having an input and an output table, which is what we talked about yesterday. So you're going to have an x and a y. In our directions, it told us the domain is going to be this right now. Tell me one more time. Is the domain the x or the y? The x, okay? If you don't know that, you've got to memorize it. So we're going to do -1, 0, and 1. All right, so since we know that this is the x, we're going to go ahead and get rid of these x's over here. What will my first x be? -1. Okay, all you're doing, remember, is you're taking this and you're plugging it in over there. What will my next x be? 0, and the final one? 1. Okay, so now, as you can see, we just input these, so we're going to be getting an output. Remember, our y is our output, or it's our range, either one. So let's do this first one first. What's -1 plus 4? 3. Next one, 0 plus 4?
4.
And final one is 5. Okay, so this is your input and output. From this input-output table that we have right here, we can give ourselves an ordered pair. Now, we haven't talked about ordered pairs in a while, but we always know it's an x that comes first and then a y. As you can see right here, I have an x and I have a y. So I'm going to go ahead and plug in -1 and 3 as my ordered pair. So it's simply another way to write this. You're just writing it right there. What would my next ordered pair be? 0 and 4. What's my next one?
1 and 5.
1 and 5. Now, let's see if you guys remember this. How many of you guys remember graphing things on a coordinate plane with x's and y's? Okay, so that's something we're going to go ahead and do right now. We're going to make ourselves a coordinate plane. This is similar to kind of what you want your coordinate plane to be. When you're going left to right, is that your x or your y? This is your x. When you go up and down, what is that? Your y, okay? So let's go ahead and look at this first point right here, -1 and 3. As we can see right here, -1 is my x, so am I going left and right or up and down?
Left.
Left and right, okay? Now the -1 is going left, so I know that I am traveling this way right here to the -1. Then I have to go to a 3. Is that up, down, left, or right? It's up because it's a y and it's going in a positive direction. So I know I went left -1 and then up +3 will bring me to land right about there. Okay, so back when we did this before, we would start labeling this like that's point M or P or Q. You don't have to do that because we are labeling an entire graph at this point, okay? The main thing you want to remember is always start at the origin. What is the origin? 0, 0, okay? So I start at the origin and then I move left or right first and then I go up or down. Let's go to the next one. I'm going to label the ordered pairs 0 and 4, okay? So the 0, do I go left and right, up or down? I'm going to stay right there. I don't have to move anywhere. So I will not go left and I will not go right. Now I've got to focus on this 4 right here. Which direction will I go for that 4? Up, because that's my y, okay? So you are going to stay at 0 and then go up to 4 and plot your point. I have one more ordered pair that I want to do. Who would like to come up to the board to show me where it is? Let me have Jakari come on up. Okay, guys, help him out. He has to start where?
At the origin.
At the origin, okay? So go and put your finger on the origin. Now you are moving to a 1. Which direction is that? Okay, he's going to the right 1 and then where? And then up to 5. That is correct. Okay, so that is where it lands. Great job, Jakari. Thank you. Okay, now all you're going to do is basically connect the dots, and you are going to draw a line right there. Now, listen, I only require you to do 3 points, but the arrows are here because it could have continued. The next one, you would have found that it was a 2 and a 6, and then a 3 and a 7, a 4 and an 8. Does that make sense? So it would have kept going on and on forever, but for us, I only need you to do 3 points. So we're going to be graphing this one the same way that we did problem A. How many domains does the original instructions tell us?
3.
3. So we're going to go ahead and rewrite our function 3 times. Now we want to make an input and an output table. So you need your X and your Y. Once again, the instructions told us our domain. Is the domain the X or the Y? It is the X. So what are my 3 X's?
-1, 0, and 1.
-1, 0, and 1. So now what we're going to do is we're going to go ahead and get rid of the X because we are going to try to plug that right in there. Whenever you have a number next to a variable, what does that mean?
Multiply.
Multiply, okay? So I'm going to be multiplying by -1, multiply by 0, and multiply by 1. So for your test and quiz next week, you are able to use a calculator if you need to, but let's just talk through it, okay? If you have one negative number and you're multiplying or dividing, your answer will always be negative, okay? That negative number wins out. If you have 2 negative numbers, they become a positive. So here I have -3 times -1. What is that?
3.
+3, okay? Because 2 negatives always equals a positive. Next up, -3 times 0.
0.
0, and the final one, -3 times 1.
-3.
-3, okay? So that is your input-output table. Go ahead and box it. From that input-output table, I am able to get my ordered pair. What's the first ordered pair that we have there?
-1 and 3.
-1 and 3. Okay, remember your X always comes first and your Y is second. Michael, what's the next one? 0 and 0. Katie, what's the next one? 1 and 3. Okay, so now I have my ordered pair, and this shows me these are the 3 points that I'm going to plot on my graph. So to the right, I want you to go ahead. Now you can see my range looks like it goes about up to a 3, so you don't have to even go all the way out to a 5. For me, I'll just do it to 4. Remember, it's important, do not label the boxes, just label your lines. All right, as Kyla comes up to plot our first point, where should she start?
Origin.
At the origin, which is 0, 0. Where do you go next? To the left for -1 and then up to 3. Okay, very good job. So then you plot your point right there. Choose someone to come up to do the next one. All right, as he comes up, show us where 0, 0 is. Very good. You do not have to move left or right. You just stay right there. Who wants to come to do the next one? Let me have Michael come on up. All right, guys, where does he start? At the origin, 0, 0. Then you go to a 1 to the right, and then -3 down 3. Very good job, okay? What do I do next, guys?
Plot your points.
I connect the dots. Okay, so once you have connected the dots, remember your arrow means this is continuing to go on and on forever. We only plotted 3 points, but it can continue going on, okay? Does that look like a line?
Yes.
Yes, it's a nice straight line, okay? We're going to talk about that line here in just a second. All right, let's talk through these two. A linear function is a function whose graph is a line, okay? So those last 2 graphs we just did they look like lines?
Yeah.
Yes, they did. So those were linear functions, okay? So you can even see right here, what word do you see at the beginning of linear?
Line.
You see the word line, okay? So just remember, it's a function whose graph is a line. Next up, vertical line test. When drawing a vertical line anywhere on the graph, it is a function if it only intersects the graph 1 time. Vertical, is that up and down or left and right? Up and down, thank you, all one of you, okay? So I'm going to give you an example here. Let's just imagine that I have a coordinate plane. Okay, so I'm going to do 2 of them. Let's imagine that our graph looks like this. Okay, does it look like a line? Yes, it does. Okay, now let's do a vertical line test. As you said, up and down is vertical. So you're just going to draw a dotted line up and down. How many times did my vertical line or my dotted line pass through that red graph that I drew? Only 1 time, right there. Okay, so that means it is a function because it only passed through 1 time. Now let's imagine that I had a graph that looked like this. All right, does that look like a line? No, it looks like a curve, okay? It's going from left to right, and it's definitely not a line. But let's do the vertical line test. So you just take a dotted line and you pass it through. How many times did I pass through that dotted line?
Twice.
2 times, 1 up there and 1 down there. So this would not be considered a function because it did not pass the vertical line test, okay? So that's how you tell if something is a function or not. Number 2 is asking us to tell whether the graph represents a function of x. And if it does, tell whether the function is linear or nonlinear. Okay, so let's talk about linear. What does linear mean?
That has a line.
Okay, it's a line. What does nonlinear mean?
Doesn't have a vertical line.
All right, if you look in the word, it looks like no line. Okay, so let's look at the first one. How can I tell if something's a function or not?
Draw the dotted line thing.
The vertical line test. Remember, it's a line that goes up and down. How many times did I pass that red graph?
One.
Only 1 time. If I only pass once, is it a function?
No, yes.
Yes, it is, because it only passed 1 time. Remember, yesterday we talked about for every input, there's only 1 output. So this is telling us it only passed 1 time. That means it's only 1 input for every output. Now, does that look linear or nonlinear?
Linear.
That is linear. Why?
Because it only passes 1 time.
Because it looks like a line. That's why something's linear. How do I tell if something's a function or not?
You have to do the line test.
Vertical line test, all right? So you can choose anywhere you want. I chose to do this one to the right. You could have done it to the left. It doesn't matter either way. Gabby, how many times did this pass my graph? Only 1 time, okay? It passed it through right there. Therefore, it is a function. Looking at that function, is that linear or nonlinear?
Nonlinear.
Nonlinear, why?
Because it's not a line.
It's definitely not a line. Okay, it's more like a U shape, therefore it's not linear. Let's go to the next one. I'm going to do my vertical line test. Once again, you're just going to choose anywhere going up and down. How many times did that pass my vertical line test?
Twice.
2 times. It passed up there and down there. Therefore, you will write, this is not a function. Now, if something is not a function, you don't have to tell me whether it's linear or not. But if you were going to, is that linear or nonlinear?
Nonlinear.
Nonlinear because it's not a line. Tonight's homework is only going to be 8 problems because I know some of these take a little bit longer than other problems that we've had. So page 356 is going to be your homework for tonight.